Where is your mind right now? Stop. Before you read another word, ask yourself this: where are you? Not where your body is, not where your phone is. Where are you? The thing doing the asking, the awareness behind your eyes, the presence that is somehow reading these words and understanding them, and maybe even feeling slightly unsettled by the question. If you said, "in my brain," congratulations, you just repeated one of the most confidently held assumptions in all of modern science. And here's the thing: nobody actually knows if it's true. That's not a fringe idea. That's not mysticism. That's the honest, uncomfortable position of the world's leading philosophers of mind, neuroscientists, and physicists. Consciousness, the sheer irreducible fact that there is something it is like to be you, remains the deepest unsolved mystery in all of science. We have mapped the human genome. We have detected gravitational waves from colliding black holes a billion light-years away. We have split the atom and unraveled the double helix. And we still cannot explain why, when light hits your retina and neurons fire in your visual cortex, you actually see red. Not just respond to red. Not just process red. See it. Experience it. Feel its redness. Richard Feynman, one of the greatest scientific minds who ever lived, was famously comfortable saying, "I don't know." He believed that intellectual honesty, even when it meant sitting in uncertainty, was more powerful than any false answer. And on the question of consciousness, Feynman was characteristically candid. He once said that the most important thing is to not fool yourself, and you are the easiest person to fool. When it comes to consciousness, science has been fooling itself for a long time by assuming the question was already answered. It hasn't been, not even close, and exploring why takes us on one of the most extraordinary journeys in the history of human thought. The hard problem nobody talks about. Imagine you're a neuroscientist with every tool at your disposal. You can scan a living brain in real time, watch neurons fire in milliseconds, trace the exact cascade of electrochemical signals that travel from your fingertip to your cortex when you touch a flame. You can map it all, every synapse, every neurotransmitter, every pattern of activation, and yet you still cannot explain this. Why does any of that feel like anything? This is what philosopher David Chalmers famously called the hard problem of consciousness. And it really is hard. Not hard in the way that calculating orbital mechanics is hard, or you just need better tools and more computing power. Hard in the way that makes you question whether the tools you're using are even the right kind of tools. Here's the distinction: the so-called easy problems of consciousness, and Chalmers calls them easy not because they're simple, but because they're at least theoretically tractable. Include things like explaining how the brain processes sensory information, integrates signals, regulates attention, or produces language. These are deeply complex, but they're in principle answerable through neuroscience. More scanning, more data, better models. But then there's the hard problem. Why is there subjective experience at all? Why, when your brain does all this processing, does it feel like something from the inside? Why isn't it all just happening in the dark, automatically, with no one home? Think about it this way. Imagine building a robot that can detect color. It has sensors for wavelength. It processes that information. It produces the appropriate behavioral output. It might say the word red when shown a red object. But does it experience red? Does it have any inner sense of redness? Or is it just a very sophisticated calculator? Now replace robot with human brain. What is the additional ingredient that turns information processing into experience? What flips the lights on? That question has no accepted scientific answer. And that's what makes this so fascinating. Where neuroscience gets stuck now, you might be thinking, okay, but isn't it obvious that consciousness is in the brain? If you damage the brain, you change consciousness. If you go under anesthesia, consciousness vanishes. If you take certain chemicals, consciousness transforms dramatically. Doesn't that prove the brain produces consciousness? This is where we need to think carefully, because correlation is not the same as production. Consider the analogy of a radio. If you smash part of a radio, the music changes or disappears. If you adjust the circuitry, the sound transforms. If you destroy the radio entirely, you hear nothing. But none of that tells you that the music is inside the radio. The radio is a receiver and transducer. The music exists elsewhere, transmitted through invisible waves, and the radio makes it audible in a particular location. Now, this isn't a claim that the brain is literally a receiver for some external consciousness floating around the universe. That would be getting ahead of ourselves. The point is more subtle. The fact that brain changes correlate with consciousness changes tells us that the brain is intimately involved in consciousness. It does not tell us that the brain generates consciousness any more than a damaged radio generates music. The philosopher and cognitive scientist Thomas Nagel made a related point in his landmark 1974 paper, What Is It Like to Be a Bat? Bats perceive the world primarily through echolocation. They emit ultrasonic pulses and construct a rich inner map of their environment from the returning echoes. We can describe this process in complete neurological detail. We can explain every aspect of how the bat's auditory cortex processes those signals. But we cannot know what it is like to be a bat experiencing that echolocation. There is an irreducible subjective interior to the bat's experience that our third-person scientific descriptions simply cannot capture. And if that's true for bats, it applies just as powerfully to human beings. Every brain scan, every neuroscience experiment, every fMRI study looks at consciousness from the outside. Science, by its very methodology, is a third-person enterprise. Consciousness, by its very nature, is first-person. This asymmetry may be the deepest structural problem in all of science. Feynman, quantum mechanics, and the observer. This is where things get genuinely strange. And this is where Feynman's own work becomes directly relevant to the problem of mind. Feynman was one of the architects of modern quantum mechanics. Specifically, he developed what's called the path integral formulation, a breathtakingly elegant way of understanding how quantum particles behave. And at the heart of quantum mechanics is something that nobody, including Feynman, was ever fully comfortable with: the role of the observer. In quantum mechanics, particles don't have definite properties until they are measured. An electron doesn't have a definite position while it's unobserved. It exists in a superposition of all possible positions simultaneously, described by a probability wave called the wave function. When you measure it, the wave function collapses and the electron appears at one specific location. But here's the question that kept Bohr, Heisenberg, Schrödinger, Einstein, and Feynman up at night. What counts as a measurement? What counts as an observation? When does a quantum superposition collapse into a definite reality? The standard Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg in the 1920s, essentially said, when a conscious observer becomes aware of a measurement result, the wave function collapses. Stop. Think about that for a moment. One of the most successful scientific theories in history, tested to extraordinary precision in experiments worldwide, appears in its most straightforward interpretation to require consciousness as a fundamental ingredient in physical reality. Now, Feynman himself was deeply suspicious of any overreach in this direction. He famously said that nobody understands quantum mechanics, meaning that the mathematical formalism works perfectly, but its philosophical interpretation is genuinely murky. He was uncomfortable with mystical extrapolations, and that's the right scientific instinct. But the question won't go away just because it's uncomfortable. Or when Schrödinger, who gave us the wave function and whose equations underlie all of quantum chemistry, wrote a deeply profound and underappreciated book near the end of his life called What is Life? In it, he speculated that consciousness might be fundamentally singular, that the appearance of many separate conscious minds might be, in some deep sense, an illusion arising from one underlying awareness. This was not Schrödinger wandering off into mysticism. This was Schrödinger, one of the founders of quantum theory, genuinely wrestling with what the physics seemed to imply. The quantum brain. Science or speculation? So, does quantum mechanics actually play a role in consciousness? This is where we need to separate speculative ideas from serious scientific proposals. The most prominent serious proposal is the one developed by mathematical physicist Roger Penrose and anesthesiologist Stuart Hameroff. Their theory, called orchestrated objective reduction, or Orch-OR, proposes that consciousness arises from quantum computations inside structures called microtubules, tiny protein scaffolds found in virtually every cell, including neurons. Penrose came to this idea from a fascinating direction. In his landmark book, The Emperor's New Mind, he argued, controversially, that human mathematical understanding involves a kind of insight that cannot be replicated by any classical algorithmic computation. He drew on the famous incompleteness theorems of Kurt Gödel, which showed that any sufficiently powerful formal mathematical system contains true statements that cannot be proven within that system. Penrose argued that human mathematicians can perceive these truths in a way that transcends formal computation, which suggests, he claimed, that something non-computational is happening in the brain. If the brain isn't a classical computer, what is it? Penrose turned to quantum mechanics, and then he teamed up with Hameroff, who had been studying microtubules independently and believed they might serve as quantum computational elements in neurons. The theory is controversial. Many neuroscientists argue that the brain is far too warm and wet for delicate quantum coherence to survive long enough to matter. Quantum effects, they say, get washed out almost instantly by thermal noise. But here's where it gets interesting. Recent experiments have shown quantum coherence playing a functional role in biological systems that were thought to be too warm and noisy, including photosynthesis in plants, navigation in birds using quantum effects in their eyes, and even enzyme reactions in our own bodies. The frontier of quantum biology is forcing a reconsideration of how robust quantum effects can actually be in living systems. Whether or not Orch-OR is correct, and the jury is genuinely still out, the conversation it opened has been enormously productive. It forced neuroscience to confront the hard problem directly, rather than assuming it would dissolve as we learned more about neural correlates. 3 thought experiments that break your brain. Let's try 3 thought experiments. These are the kinds of exercises Feynman loved, not because they give you answers, but because they sharpen the question. Thought experiment 1. The philosophical zombie. Imagine a being that is physically and biologically identical to you in every single way. Every neuron fires in exactly the same pattern, every chemical in exactly the same concentration, every behavior is indistinguishable from yours. But there is no inner experience, no one home. The lights are off. There is nothing. It is like to be this being. Is such a being conceivable? If yes, and most philosophers agree it is at least conceivable, then consciousness is not simply identical to physical processes. There is something extra, something that the physical description leaves out. Thought experiment 2. Mary the color scientist. Mary is a neuroscientist who has spent her entire life in a black and white room. She has learned everything there is to know about color, the wavelengths of light, how the retina processes them, how the visual cortex responds, every single physical and biological fact. Then one day she leaves the room and sees a red rose for the first time. Does she learn something new? Most people's intuition says yes. She knew all the facts, but she didn't know what red looks like. And if she learns something new, a new experiential fact, then experiential facts are not reducible to physical facts. Consciousness contains information that no amount of third-person science can fully capture. Thought experiment 3. A doubled brain. Neuroscientists have performed a remarkable series of experiments on patients who have had the corpus callosum severed, the thick bundle of fibers connecting the brain's 2 hemispheres. In these split-brain patients, the 2 hemispheres begin to act almost independently. You can present information to one hemisphere that the other doesn't have access to. In some experiments, the 2 hemispheres even give different answers to the same question. So now ask yourself, how many conscious experiences are happening in a split-brain patient? 1? 2? Something in between? The question reveals that we don't actually have a clear framework for how to count to units of consciousness. And if we can't count them, we don't understand them. Integrated information and the panpsychists turn not all responses to the hard problem take the quantum route. One of the most mathematically sophisticated is the integrated information theory developed by neuroscientist Giulio Tononi. His theory proposes that consciousness is identical to a specific kind of information structure, a measure he calls phi, which quantifies how much integrated information a system contains. The more a system's parts are informationally interconnected and interdependent in a holistic way, the higher its phi, and the more conscious it is. The striking implication of IIT is that consciousness is not unique to biological brains. Any system with sufficiently high integrated information is, to some degree, conscious. Your laptop might have a tiny sliver of consciousness. A simple thermostat might have an infinitesimally small but non-zero amount. This is called panpsychism, the view that consciousness or proto-conscious properties are fundamental features of the universe, present to some degree in all physical systems, and that what we call human consciousness is a particular complex organization of something that was always there in simpler forms. Panpsychism sounds strange, even outlandish, but consider this: it may actually be the most parsimonious solution to the hard problem. If consciousness is a fundamental feature of reality, like mass or charge, then you don't have to explain how it somehow emerges from non-conscious matter. Emergence is the mystery. If it's always there, there's nothing to emerge. You just need to explain how it organizes into the rich, unified experience of a human being. Philosophers like David Chalmers, Galen Strawson, and Philip Goff have all argued with varying degrees of commitment that some form of panpsychism deserves serious consideration, not as metaphysics or mysticism, but as a rigorous philosophical response to a genuine scientific gap: the view from inside the universe. Here's something Feynman said that feels particularly relevant here. He pointed out in his own characteristically direct way that scientists are part of nature trying to understand nature. We are not outside observers looking in. We are the universe examining itself. And that framing is quietly revolutionary when you apply it to consciousness, because it suggests that consciousness is not some strange intruder in a physical universe of blind matter. Consciousness is the universe's way of knowing itself. The atoms in your brain are the same atoms forged in stellar explosions billions of years ago. The electrons maintaining your synapses are the same kind of electrons that, according to quantum mechanics, behave as waves until they are observed. You are a part of nature that has somehow become aware of being part of nature. The physicist John Wheeler, another giant of 20th century physics and a contemporary and colleague of Feynman, took this idea seriously enough to build a cosmological framework around it. He called it the participatory universe. Wheeler argued that the universe requires observers to give it definite existence, and that observers are not incidental to cosmic history, they are participants in it. He proposed the striking idea that our acts of observation today, in some quantum mechanical sense, reach back and help define the past. Whether or not Wheeler's participatory universe is literally correct, his insight captures something important. The standard scientific picture draws a sharp line between the observer and the observed, the subject and the object, the mind and the world. Quantum mechanics has repeatedly blurred that line, and consciousness sits right at the point where it blurs most completely. What we actually know, and why that's beautiful. Let's be honest about where the science stands. We know that the brain is necessary for human consciousness, at least as we normally experience it. We know that specific brain regions correlate with specific aspects of conscious experience. We know that neural activity is intimately connected to perceptual and cognitive processes. These are real, important discoveries. What we don't know is whether the brain is sufficient for consciousness, whether it generates it from scratch, or whether it somehow channels, organizes, or expresses something more fundamental. We don't know whether consciousness is an emergent property of complex information processing, or whether it's a fundamental feature of the universe that complex systems simply express more richly. We don't know whether quantum effects play a meaningful role in neural computation. We don't know where, precisely, the threshold of consciousness lies, or even whether there is a sharp threshold at all. These are not failures of science. They are the frontier of science, and the frontier is where the most exciting discoveries live. Feynman had a beautiful way of talking about the difference between knowing the name of something and actually understanding it. He used to tell the story of his father teaching him about birds. His father would point to a bird and say, "I can tell you the name of that bird in every language in the world. But at the end, you'll know absolutely nothing about the bird whatsoever. The name doesn't tell you how it finds food, how it courts a mate, how it navigates thousands of miles without a map. Knowing the name is not the same as knowing the thing. We have named consciousness, we have classified its correlates, we have mapped its neural signatures, but we don't yet know what it actually is. And that should not depress us, that should thrill us. The most personal mystery in the universe. Here is perhaps the most remarkable thing about the mystery of consciousness. It is simultaneously the most distant and the most intimate question in all of science. The furthest, most exotic objects in the known universe, black holes, neutron stars, the cosmic microwave background radiation echoing from the first moments after the Big Bang, are things we study from the outside, with instruments, through data. They are remote. They are other. But consciousness is the one thing you have direct, unmediated, absolutely certain access to right now. René Descartes, whatever his other mistakes, got this exactly right. You can doubt everything else, the existence of the external world, the reliability of your senses, even the integrity of your own memories. But you cannot doubt that there is experience happening. You cannot doubt that there is something it is like to be you right now, reading these words, feeling whatever you feel. That is the one thing that cannot be taken away by any skeptical argument. The philosopher-scientist who truly cracks the hard problem of consciousness will have explained not just a fascinating phenomenon among many fascinating phenomena. They will have explained the only thing any of us ever directly know. Every experiment ever conducted in the history of science was ultimately conducted in consciousness. Every discovery was made by a conscious being. Every theory was formulated in a conscious mind. Consciousness is not just one more thing to be explained by science. It is the very medium in which all science takes place. And yet we treat it as almost an afterthought, a footnote, a hard problem to be solved once the real science is done. Maybe the reversal of that assumption, maybe placing consciousness at the center rather than the periphery of our scientific worldview, is the conceptual revolution that's still waiting to happen. Quantum mechanics was a revolution. Relativity was a revolution. The discovery that the Earth is not the center of the universe was a revolution. Each time, something that seemed solid and settled turned out to be deeply strange and open. Perhaps we are standing on the edge of the next great revolution. And perhaps it won't happen in particle accelerators, or radio telescopes, or genome sequencers, though all of those will have their roles to play. Perhaps it will happen at the intersection of physics and philosophy and neuroscience, in the strange borderland where equations meet. Experience, where matter becomes aware of itself, where the universe opens its eyes. A Feynman-style reflection. Richard Feynman once said that he thought it was far more interesting to live not knowing than to have answers that might be wrong. He found a kind of joy in uncertainty, not the resigned acceptance of defeat, but the active, delighted engagement with the open question. The nature of consciousness is the ultimate open question. It is the one place where the scientific tradition of relentless inquiry runs straight into the philosophical tradition of first-person reflection, and neither can proceed without the other. The physicist needs the philosopher to sharpen the question. The philosopher needs the physicist to ground speculation in physical reality. And both of them need the neuroscientist, the mathematician, the cognitive scientist, the poet, and perhaps even the meditator who has spent a lifetime attending carefully to the contents of awareness. Because here is the truth, that all of this science and philosophy is circling. Your consciousness is not just a subject of inquiry, it is the instrument of inquiry. You are not studying consciousness from the outside. You are consciousness studying itself. And in that strange loop, awareness contemplating awareness, mind reaching back to examine its own foundations, there is something that feels, however we might ultimately explain it, like one of the most extraordinary facts in the known universe. The lights are on. You are here. That is the mystery, and it is somehow the most beautiful one of all. If that question grips you, if the idea that the most fundamental mystery in science lives inside your own experience right now makes you want to go deeper, then there is so much more to explore. The territory ahead includes the neuroscience of altered states, the physics of time and its relationship to conscious experience, the implications of artificial intelligence for what it means to be aware, and the ancient philosophical traditions that have been wrestling with these questions for millennia before modern science was born. Stay curious. The best thinking happens in the questions, not the answers.